equations. Bernoulli equations are equations that are almost linear except for this one term. Now, they're not always going to appear in this nice clean form, but the idea is very simple. You have your y prime and you have your linear y, but then you also have this other y raised to some other power. And it doesn't really matter what power it is as long as it's there. It's annoying us because we're only allowed to have one linear y in linear equations. So how do we treat it? Treatment is very simple. What we do is get rid of it, get rid of whatever is annoying us, and then reform and refactor it into a linear equation by a little substitution. So let's go ahead and impose that treatment on this guy. So we have y prime plus 3y is equal to 5y to the fourth. So this is perfectly linear except for him. He's very, very, very annoying. So I'm going to get rid of him. I'm going to divide both sides by y to the fourth. So I'm going to get y to the minus fourth y prime plus 3y to the minus third, and then 5 on the right-hand side, right? So now I've succeeded in getting rid of this guy, but I've made this thing really not linear. What I need for this to be linear is this guy needs to be a something to the first power. So I'm going to do exactly that. I'm going to make a substitution that's v equals y to the minus third. And the intent and the motivation is because I need him to be something to the first power. That's how we know equations are linear. So I'm going to do that, but then I also need to get rid of my y prime and such. So I'm going to go ahead and derive v to figure out if there's anything that's going to come out of it. So dv is going to be minus 3y to the minus fourth dy. So dv dt is going to be this guy divided by dt. So in other words, v prime is equal to minus 3y to the minus fourth y prime. Whoa, that almost looks similar, right? It's almost like it was meant to be. So by substituting v for y to the third, not only did we get rid of the y to the third, but we also got rid of this expression. And I wonder if that's going to happen every time. And the answer is yes, it is going to happen every time. The reason it happened is because when we started, this term had a y in it. It started with a y, but this guy didn't. So when we divided both sides by y to the whatever power, his power is always going to be one greater than him. So when we derive him, his power of y is going to come down one, and it's going to become this guy's power of y. So in short, yes, this is always going to happen. So now we can make an easy substitution back into the equation. Well, so the y to the minus 4 times y prime is just going to be replaced with v prime over minus 3, right? So minus v prime over 3 plus, then the 3y to the minus third is just going to be replaced by 3v, and then this guy is just going to be 5, right? So now we have a perfectly simple linear equation in v. So we have v prime minus 9v is equal to minus 15. And that's a very, very simple equation to solve. But remember, when you solve this equation, you're going to get v equals something. You got to go back and substitute in y for it, right? You're looking for y. So whatever you get, you're going to raise it to the power of third, to the third power, and you're going to get your y. So let's go ahead and do an example. This is sort of our learning lesson. Let's go ahead and do an example and see how it works out. So this problem, as you can see, it's not exactly mirroring that form, but we can see that it's almost got that linear look to it. Namely, it's got our y prime. There's no y's associated with that term. And then we have our y. So let's go ahead and put it in standard form, and let's see what happens. So to put it in standard form, I'm going to divide both sides by t squared. So I'm going to get 2 over t times y is equal to 1 over t squared times y to the third. Okay, so now I can see that this thing, in fact, is almost linear, right? It is, so I got my y prime, I got my y, and then this thing. So it's a Bernoulli equation because of that y to the third that's throwing everything off. So I'm going to get rid of him. I don't like him. So I'm going to divide both sides by y to the third. I'm going to get y to the y prime over, actually I'm not going to write it over. I'm going to write it as a negative exponent just because I find that easier. But you can do whatever you want. 2 over t times y to the minus second is equal to 1 over t squared. So now I'm going to say, well, I wish this were a linear term, right? Something raised to the first power. So I'm going to give that to myself. I'm going to say v is y to the minus second. And then I'm going to calculate v prime as well. So minus 2y to the minus third y prime. So now I can make the substitution. Y to the minus third y prime is just v prime over minus 2. So then 2 over ty to the minus second is just 2 over t times v. Then my 1 over t squared is just 1 over t squared. Right, so I can multiply both sides by minus 2 and get v prime minus 4 over tv is equal to minus 2 over t squared. And that equation is very simple and linear in v, and we can solve it very easily. As you can see, Bernoulli equations they're not difficult, they're not complicated, they're not even that the procedure of making it linear isn't even that long. All you got to do is make sure you can spot it when you see it. And remember, what you look for is your y prime, your y, and then that little y to the something term that is sort of throwing everything off and making it not linear. And the way you do it, and the way you deal with it is just get rid of it and then make the substitution to make it linear, and then everything will take care of itself. Okay, so there you have it. That's Bernoulli equations.